Okay, we're out on the Swail Trail doing some survey work. We got our pole set. This is our reference point, the base of that tree. And we have our laser level here, and this is our first one, which goes this way. And then that way, and then down to there. We also did some video, or some measurements this way at an angle and this way at an angle, because we would like to trench and bring up that water in here. This is our brush pile, and here is, our 0 point was right here, and then we went straight down this way. You can see all the way down there, and then we went back up this way at 10 feet or so. I guess I could make a video of me doing it. We have to do the other ones, and it's kind of cold today, so my fingers are cold, so maybe I will set up the camera next time. So those are the field notes I took of all the distances and measurements, and now I have put it into Excel, so I will show you what the survey data from the first part of that trail work looks like. So this is the swale, the blue line. The swale trail is just north of that, and here's the main trail that comes in and tees to it. And then this is the section that we're looking at doing drainage in. Here, so we're going to call the swale trail the A line. B line is this section here. C line is this one here. So you can kind of see B is going to tie into C, just because that's how it laid out well in the topography. And we have 11 of these to do, right? Because I think basically it's farming, old farming, right? So you used to drive the tractor down here with the discs or whatever, and turn and pile up the dirt along the swale. So this section here is higher than this section, but you get all these like furrows coming down here, and that's kind of where the drainage wants to go. Okay, so let us, and like I said, this is like a picture, the main trail coming up from the swale, and this is where my reference point is. So that when I do all these other ones, I can, for almost all of them, I can see this point and reference all the data back to that. So here's the distances, here's my elevations, reference day, and then here's my feet going backwards from the swale, and here's my elevations going up from the swale, and all my notes. And that's looking south, so here's the trail goes this way, and there's a low spot in the trail, and we're going to try to drain it down that way. And then looking up this way, we want to try to collect the water coming down and then have it go across and down this way. All right, so here's what the data shows. This is feet from the bottom of the swale, so it goes up this way. And this is elevation from the bottom of the swale in feet. And here is what it looks like. Well, here's our trail up here. That's the low point. The center line of the trail is a low point. And this is going north. You can kind of see it gets higher. And then this is going south towards the swale. You can kind of see where you have it dip down a bit, but then it forms like a bowl down here too, but then it drops off sharply towards the swale. This line is 0.5% grade, so 6 inches out of 100 feet, which is minimum for drainage. So if we start like, this is like the high water mark for the swale when it's running pretty good. So if we draw 0.5% grade back, you can kind of see that we have, well, let's see there, it's half, one, half, got like 2 foot of elevation change, which for this kind of property is awesome. So this I think is a clay bowl. Like you scrape off some topsoil, I think there's clay and it forms a bowl here. So I want to try to get that drainage a foot below here. So I say let's start there, put a 0.5% grade. It'll take us down there. We still got plenty of drop. We still got like another foot drop. So, you know, this would be 6 inches of cut. This is like, you know, almost a foot. So all right, so this is a foot. This is like, you know, 6 inches. This is a little bit more. So not that deep of a trench for most of that, you know, foot here. So I'm thinking that is a good first attempt. And then on the high side of the trail going north, I don't need to get that low. I mean, the water, if we can drain this thing, then all I need to do is just collect the water up here, get it to here, so it's in like one localized spot crossing the swale trail, and then hopefully this will then drain it away. So that's my thought for we'll call it the B line. That's the first one. And now we're calling this the C line. So this is, you know, well, I don't know, 20 feet west. So this is looking north. So we're going to collect the water from up here. This is a low spot. We want the water to go across, and then we're going to go straight down to the swale. And then the B line is going to connect it over here. So same graph, just, you know, different. So feet from the swale, elevation from the swale. So this is all the same. This is just a little bit different. So this is the trail up here. You can kind of see it has a bowl effect to it. Now, interestingly, north, you know, when we go northeast, it's higher. When we go northwest, it's actually lower. So I think this part, we're going to have to drain to a different line, like maybe the D line, which is going to be the next one. We'll pick up and drain it that way, because it's not going to be easy to drain this up to here. Same thing, drop it down a foot, around 0.5%. That's what I'm thinking. So, like, I don't think I even have to trench all this far. I think I really just have to trench from like 20 up to 60, so 40 feet of trenching. That's like, you know, foot to 6 inches, 6 inches to a foot deep that I have to do. So I probably just, first attempt, probably just try one of these by hand. Just get the shovel out, mark a path, and start trenching and see how it happens. And just because the B and C are going to share this common segment up to here. You know, the green is the C, which is a straight line, and then the B comes up to here, but then it takes a 45-degree turn, so it gets a longer distance to get up here. But you can kind of see the bottom of both of those about the same. So I think there'll be a good first attempt.